Hi everybody. I wanted to throw a quick video together to talk about one of the kits I make called the LeRhone, and talk about some of the processes it takes to get it ready to ship and actually how it ships. So sitting right here is 99% of the LeRhone kit. One of the things to keep in mind is that most people don't appreciate how many parts there really are in this kit. There's 147 parts excluding bolts and nuts. Including the bolts and nuts, I haven't added it up. So the bolts and nuts are only for show and also to help glue and secure things together. That they really don't thread together, but the real airplane had bolts and nuts on it, the real engine. So what I wanted to talk about was, you get the 9 cylinders, you get some bags. In the bags, like this one has all the intakes for the intake manifold. This bag here has the cylinder heads and the valves. And then this one has basically all the valve train parts excluding the valve. So this has the push rods, the rocker arms, the rocker housing, the fake bearings for the rocker housings. It has the basically a guide for the bottom of the push rod that goes into the crankcase. And then it has the axles that go through the rocker arms. One of the things I don't know if people appreciate is most of the holes that are made on one of the kits have to actually have a drill run through it because 3D printing is not that precise. Okay, depending on how the first layer goes down, the hole can be smaller because it squishes out the material. So there's an awful lot that goes into it. The biggest reason I wanted to kind of throw this video together and talk about the processes is I had a troll end up on one of the groups I belong to and kind of attacked me and said that I'm using my acetone vapor bath as a way to make people think I can charge so much for my kits. Well, I want to kind of answer that in 2 ways. First of all, I'm not sure what they think is too much for a kit. Because when you think the LeRhone, I have about 70 hours of CAD time into it, which I'll never recover. And then when I think about the actual 3D printed parts, I take the raw cost and double that. And the reason I double that is because I have to take the time that my machine runs because it's wear and tear on my machine on a 3D printer. And then I take $25 an hour for any labor I have to put into it. So basically I end up with like a $125 kit where my true raw cost in it are around 75 bucks, 80 bucks. So I'm only making between 30 and 38% margin on a kit. And all of that goes back into my hobby because I've got a daughter that's going to go to an Ivy League school in a couple of years. And I'm just not going to be able to spend on the hobby like I have in the past. So I've got to find a way to supplement my hobby money. So I don't see how anybody could say that I charge a ridiculous too much amount for my kits. If anything, I had many people email me and tell me I should mark them up more, which I'm not going to do right now. Keep in mind, the whole reason I started doing this because I had all of my friends and fans reach out and they started seeing me make 3D kits and say, Damon, you've got to sell these. I want to buy one. So now let's talk about how I really am able to manufacture it. If I'm building a one-off like this right whirlwind here, this is for a quarter scale spare in St. Louis. I can basically look at how much R&D and how much testing and the methods and processes to make something like that as a one of. But if I'm going to mass produce something, I need to have processes. So when I look at the LeRhone, the most important process for really making this kit strong enough that it can be shipped and it will stay together on a model airplane and make it so it's paintable is with the acetone vapor system. And now I want to explain a little bit more about that, because this is what kind of blew me away about this troll, who has never done any of this, has no experience in this, and hasn't done any testing, happens to know more than I do. And that's fine. There's weird people out there. But I want to talk about the science behind this for a minute. When you think about what happens in an acetone vapor bath, basically the acetone fumes are melting the outside layer of the ABS. Depending on how deep that melt goes is how shiny it can get. So the problem I had early on was, if I melted it enough to make it shiny here, the fins would sag or droop, or they would settle. And I was really worried I wasn't going to be able to get the process to work the way I wanted, because I need to have everything shiny like this one here, because this has been through an acetone vapor bath and this one hasn't. This one's ready for paint and it will look like a casted part. This one right now, if you painted it, you'd still be able to see all the layers through it when I 3D print it. And actually this is for a Pratt & Whitney, so ignore that. This is the LeRhone right here. And this is one of the right cylinders. But the problem I had was I needed to slow down the process. Keep in mind, acetone is extremely flammable. So I use a small aquarium. I don't want enough gas that if it ever detonated, it could do a lot of damage. Keep in mind, gases are much more dangerous than liquids. When it's in a gaseous state, it is extremely volatile. So a buddy of mine who used to work for NASA that worked in polymers and plastics and worked with acid baths, and him and I were talking, and he told me there is ways to slow down the acetone. Now this person who was a troll said, well, all you got to do is put an air bottle on it. If you have an oxygen regulator in there, and you could have valves, and you could maintain an exact environment in there, yes. But you still have to vent it into the atmosphere, and I don't want acetone vapor being vented out when the level's too high. So my buddy told me I could thin it with water, which in my early testing worked really well. And it should work for 95% of you, if you just thin it a little bit. Now, if you put less acetone inside the aquarium, it evaporates quicker, and that's not what you want. You want it to penetrate into the surface of the ABS. So there's a science to this. If you have just 1 ounce in there, it might evaporate out in 20 minutes and you lost all the melting reaction you needed. However, if you have 2 ounces of acetone and 5 ounces of water, the acetone from my experiments, lasts a lot longer, but the amount, the intensity of the acetone is much less in that environment. Now, there are a couple of chemicals I add to it, which I'm not going to share with you because it makes the flash point really, really high on, not high, it makes it really easy to ignite the acetone. So any static electricity. One warning I want to put out there. Anytime you do an acetone vapor bath, if you're using electric motors to move the air around the way I do, they have to be brushless. You do not want any sparks in that tank or you can have a fire. Now I want to talk about those fans. I found out by running those fans really, really fast, on a thick piece like this, it will penetrate quicker into it. When I move the fans really slow, it gives me a much slower process. Now on the LeRhone, a couple of things I want to talk about. When you get a kit, you get like the crankcase like this. These are pretty heavy parts. Okay, so I can do a higher acetone level in the tank and melt this without drooping the parts. Okay, keep in mind the acetone, when I melted a part for 30 minutes, ABS, I got exactly 1/10 of a millimeter penetration into the material of smoothness or of the melted surface, 1/10 of a millimeter. So these parts I can let melt. You can see how shiny they got, because I don't care if it goes down to 2/10 on something like this. However, when you have a fin where the outside edge of the fin is only 2/10 of a millimeter, if you have penetration of 1 from each side, it will make this soft and sag. Also keep in mind, when you take it out of the acetone vapor bath, it's still melting the surface for up to 45 minutes to an hour, depending on how high the concentration was that you did the vapor bath in. If you get this looking perfectly silky smooth while it's in the tank and then take it out and let it sit for an hour, chances are it might melted too far that some of this stuff droops, or you actually see runs in it like paint. So I hope this is really beneficial to you. The biggest problem with trolls is they'll say things on blogs and on groups where other people look at them and wonder, oh, is this person right? And if they've never done it, they have no experience, they shouldn't be trying to knock why, you know, a certain process would or wouldn't work. What was really funny about this troll was he referred back to that video a year ago that shows them taking that frog and sticking it in an acetone vapor bath and melting the outside, making the frog real smooth. And it's a ABS frog, not a real frog. A real frog wouldn't live very long in the acetone vapor bath. But that frog was a solid object. Now, if it had ears on the frog, if he would have left it in there long enough, it would have melted the ears off it. You leave ABS and acetone overnight, and you'll have a pancake of ABS in the morning. So it's funny that somebody will just go out on the internet and find an acetone vapor bath and then try to shoot down what I'm doing and say that I'm being an opportunist. That's just going to happen in life. I don't care about those people, but I care about them when other people are reading about their ignorance. So I want everybody to understand that now I'm not saying there's a better process, that there's not a better process. I'm saying what works for me, because I need to get repeatability reliable. So if I'm doing 9 of these, which are 18 parts of these cylinders, I don't want to stick them in there and have them fail. I will show you what a failure looks like. Hopefully over here you've been seeing some pictures pop up, but this right here is flat out where I left it in 10 minutes too long and it started to warp and melt the entire cylinder. So for me, there is a science. I have about 95 different configurations that I can set up all my 3D models in when I'm printing them and I'm batch making them. I have 10 processes when I put it in the acetone vapor bath, depending on the thickness and the size of the part. Another thing is, if this was a half scale cylinder jug, it's a much different process than when it's a quarter scale and you have 2/10 thick fins. I mean, 2/10 millimeter thick fins. Okay? That's really thin. And you don't want it to melt and sag. So when you buy a LeRhone kit, every part except the artificial ball bearings is acetone vapor bath to give you the ability to paint it and not have any lines. I don't know of anybody else out there that's doing this as a mass producible product for model replica engines. Okay, doing the cylinders on a engine, the cooling fins on an engine head, I found out is extremely hard. And just to take acetone, put it in a tank, stick your cylinder in there, let it sit for a certain amount of times, I guarantee you the fins will start melting before you get a really big shiny surface on the other parts. I mean, that part right there looks painted. This is acetone vapor bath. No paint on this at all. Now, this cylinder to the right, this has been acetone vapor bath and black gloss paint, and it looks fabulous. It looks fabulous. So thanks for watching my videos. I want you to think about when you're buying one of my kits, I'm trying to make it as easy for assembly as you can possibly have. It takes a lot of time sometimes to get one of these kits ready to ship. And, you know, I think my most expensive replica engine's under $200. And, you know, there's a lot of parts in these. I mean, when there's 147 parts in this kit here without bolts and nuts, that's an awful lot of parts to make. So, thanks for watching my videos. Keep the emails coming, and have a fabulous day, everybody. Thanks.